Today we will solve the missing number Leetcode problem, and as always, we will start with the problem statement. As you can see, we have an array called nums, which contains n distinct numbers in the range of from 0 to n. And so that's basically our input, and for the output, we had to return the only number in the range that's missing from the array. And to figure it out, it's best to go through an example. Here in the example 1, we have 301, so we have total of 3 numbers. So our range is from 0 to 3. And as you can see in the input array, we have 0, 1, and 3, but we are missing number 2, which is basically our output. In the second example, it's basically the same. We have a total of 2 elements, so the range is from 0 to 2. We have 0 and 1, and we are missing the last number in the range, which is 2. In the last example, we have 9 elements, which basically means that we are starting from 0 and going all the way up to 9. And as you can see, the only number that's missing is 8. Now, the straightforward solution to this problem would be to put all the numbers from 0 to n, where n is the length of the array, into a data structure like a set, so we can easily access and check if the element exists, and then traverse through an array that's given us an input and check if each of the element exists. And once we face the first element that's not in the set, we know that's our answer. But you will be probably asked during the interview to reduce the space complexity and to try to use the nature of the input array to solve the issue without to solve the problem without any additional data structure. In that case, the first question to your interviewer should be, what's the nature of the input array? Like what kind of array do we have? And as you can see by the constraints, it's an interesting array because all numbers are unique and all numbers are in the range from 0 to n. So we can try to use that to find the solution. And how can we do that? So to solve the problem, we will use the XOR operator. And here we have our first example from the problem statement, and just a small table representing the results when the XOR operator is applied in 2 bits. So as you can see, the result of the XOR will be 0 in the case where we have the same bits, so 1 and 1 or 0 and 0. So when the bits are the same, and when the bits are different, in this case 1 and 0 and 0 and 1, the result will be 1. So how can we use XOR to solve our problem of missing number? Well, first we have to go through some interesting properties that XOR has. First property is that if we apply XOR on one bit, that can be 0 or 1, and the second operand is 0, the result of the operation will be the initial number, so the first bit. 0 is basically the neutral element when it comes to XOR, and this little sign is just XOR. And the second property is that when applied to the same 2 bits, it always results in 0. So if we apply to the same 2 numbers, the result of operation will be 0. They will cancel each other out. Also, this is true for XOR, so the order of the operands is not important. You can either do the A as the first operand or B as the first operand. The same goes if you have multiple operands. Like in this example, we have A, B, and C. We can first do the XOR on A, B, and then XOR that with the result of this operation with C, or we can first do A and C and then XOR the result with operand B. So how can we use these properties to find the missing number? So as you can see, the range of our input array, for example, in this case, we have three numbers, will be from 0 to 3. So all the numbers that we can have are 0, 1, 2, and 3. So that's our ultimate set, basically. That's one group of numbers. We can just name group 1. And the second group will be actually the input array. So in this case, we have 3, 0, and 1. And the thing is that we can we have to find a difference. You can think of a difference between two groups, and the difference is the number that's in the first group but not present in the second group, which is also the desired result of our solution. Say actually 2 in this case. So how can we use XOR to find difference between two groups? Well, first of all, because of the specific properties of the input array and the range, you see that most of the numbers will cancel each other out because of the second property here. When XOR is applied to the when we have two same numbers, they will cancel each other out, and the result will be 0. So, and also, like, we don't have to we can the order of applying the XOR is not important, so we can do for example 0 and 1, and then the result of this we can XOR with 2, and then the result of that we can XOR by 3, or we can go straight to 0 and 0, 3 and 3, 1 and 1. So each of them will cancel each other out because, for example, 3 XOR of 3 is 0. So in this case, the remainder of the operation will be 2, which is the solution of our problem. We will just go through an example of XOR on the two different numbers, so we can just see how it reiterate how it behaves. So let's say we have x equal to 3 and y equals to 5. And let's just represent that in the binary form. So the 3 will be represented as 0, 1, 1, and 5 will be represented as 1, 0, 1. And if we apply XOR on it, we will have 1 and 1, which is from our table 0. We have 1 and 0 from our table, that's 1, and 0 and 1 from our table is also 1. And this is the representation of number 6. And so the most important part here is to understand the neutral element of the XOR operation 0, so we can start with 0 and it will not affect the end result of the operation. And the second property is that if we have two of the same numbers, they will cancel each other out. And the third thing that you have to remember is that the order of operation is not important. So you don't have to follow this order. You can just XOR any number, and then with any other number, and then XOR the results with any other sub-result that you might have gotten during the execution. First, we will start by initializing the result. And if you remember, the first rule is that 0 is neutral to XOR operator, so the natural choice for the initial value of the result will be 0. Also, in the case when the 0 is really the missing number, all the other numbers will be cancelled out, and the remainder will be 0. So we will have a successful test even in that case. Then we will iterate over the numbers with the plain for loop. And the thing that you have to note here is that I variable that goes from the 0 to the end of the array presents our range of elements. So from 0 to the number to the length of the array. So what we will do, we will apply the XOR operator. And as said earlier on, the order of the application of it doesn't matter. So we can just XOR the current index, or one of the numbers in the first group, with one of the numbers in the second group. And our second group in this case is just the current element in the input array. And finally, we will XOR that result with our result variable. And then after we are done with traversing the array, the last thing we have to do is to XOR the result with the length of the array, which is basically the last element in the range. Because if you think about it, I only goes to the length of the array -1. So we have to, the last number that we have to XOR is actually the length of the array. So in the case, for example, in the first example, that would be number 3. The time complexity of this solution is linear because we only have one for loop, while we have a constant time space, constant space complexity, because we don't create any auxiliary, any helper data structures, and we operate on only on the input array.